Hi everybody, in this video we are going to be talking about 18.4.1, which is solving exponential and logarithmic equations. In this video we really put together a bunch of the concepts that we have been working on and learning, and then we add one more piece about how to solve for a particular exponent. So for example, if we look at example number 2, we might not know what that exponent is going to be, like 4 to what power is going to give us 17. And we know it would be 2 point something, but we don't know exactly what it is. And so we're going to work on trying to figure out, well, what do we do in those cases? So with that, we are going to get started. And the first one, I'm sure you all can already figure out what it is, where you're saying 4 to what power is going to give me 16. And so that's going to be x equals 2. But I want to implement the process on this problem where you already know what the answer is supposed to be when we get ready to go do number 2. So one really cool thing about taking logarithms is that you actually now have a tool in your math toolbox in order to solve for an exponent. So 100% of the time when you are needing to solve for these exponents, you are able to take the log of both sides. And so if I go like this, you take the log of both sides. So you take log of 4 to the x. And again, whatever you do to the left-hand side, you have to do to the right-hand side as well. And so we would take the log of 16 and now use your properties of logs that we know that we can do here. So using your power rule for logs, we now know that we can take this exponent and bring it down, which allows us to have x times the log of 4 equals the log of 16. And now to solve for x, you're just going to divide both sides by log of 4. And so then we would have x equals log of 16 divided by log of 4. And that, when I circled it, I shouldn't have circled it because we're not done quite yet. So then in your calculator, you would do, so like in my little simple calculator, I have to hit 16 and then hit the log button and then divide it by and then hit 4 and then hit the log button and then hit equals. And in that case, once you do that, you're going to get 2. And so you should practice that right now in your calculator. Make sure that you're going to get the right answer. And that's what we're going to do. So every time you see one of these problems where we have an unknown in our exponent, we're going to take the log of both sides. And that allows us to bring our exponent down using our power rule. And then we can solve for x. So here you have to be careful. On number 1, we can take the common log, or you could take the natural log, doesn't matter. When we get to something like number 3 though, I want you to notice how the base is e. So when the base is e, you should be taking the natural log because it's going to make our process so much easier. So we're going to take the natural log of both sides in order to solve for the x in the exponent. And then for here, you guys should tell me, which one do you think would be the easiest one to take, common log or natural log? And I hope you say the common log because the common log already has that base of 10, right? So that makes our process that much easier to just take common log on that one. Then when you see something like this, where our unknown is in the argument, so looking at how our unknown is in the argument, not in the exponent, this is one where our general method of solving is going to be convert it into exponential form. And so on each of these, what I would encourage you to do is to make sure that once we get done with today and we do the lesson, that you look back at these notes and you look back at each of the examples and say, how can I look at them and in like a second's time be able to say, okay, on this one, number 3, I'm going to take the natural log of both sides, and then I'm going to end up solving for x. On number 4, because the bases are the same, I can set the exponents equal to each other and solve for x. You could also take the log of both sides on that one. Number 8, I'm going to go ahead and convert that into exponential form and solve for x. And so you should be able to, on every single one of those problems, be able to quickly, without looking at your notes, say what the process is on how to solve for those equations. and then you know you're ready for this topic, because we're going to practice it again a whole bunch more in class, but that's how you can start working on it now, because these are the types of problems too that really catch people up on the final exam as well as any quizzes. All right, so with that, I'm going to go back to number 2, and I am going to take the log of both sides. So I'm going to take the log of 4 to the x, and I'm going to take the log of 17. And then that allows me, because of my property, my power property rule for logarithms, to bring that x down. So then I've got x times the log of 4 equals the log of 17. You're going to divide both sides by the log of 4. And let's look back up in the directions because I didn't read those, which is not great. It says solve the following equations, and we're going to round to the thousandth place if necessary, because we're definitely going to have to do that for this. So I'm going to go ahead and put squiggles instead of equals because we're going to need to do that. So take the log of 17, divide it by the log of 4. Tell me what you get. We're going to round to the thousandths place. I'm going to type it into my calculator. Hopefully you've already gotten it and you're moving on to the next problem. So I got 2.04373, and it just keeps going. So rounding to the nearest thousandths, tens, hundred thousandths, is going to be 2.044 for my final answer in here. And I am going to make note of that longer answer on my paper. So 2.04373, and hopefully you're done with the next problem by now, because I've taken enough time. I've dilly-dallied. You've solved the next one. Here we go. So because of the base e, I'm going to take the natural log of both sides. So I'm going to take the natural log of e to the 2x equals natural log of 54. That allows me to bring the 2x down. And then we've got 2x times the natural log of e equals the natural log of 54. So I want you to think about this again. This goes back to one of our properties that we're going to use. The natural log of e, again, this states, this is asking the question, e to what power is going to give me e? So e to what power is going to give me e? And it's going to be, the question mark is going to be equal to 1. So what that means is that that entire natural log of e equals 1, and I can just substitute that out like that. If you need more review on that, I would go back to your properties of logs and check that out. And in fact, it was probably even the video before that when we were discovering the rule, when we were first looking at logarithms. Okay, so now we have 2x times 1, and so now we can just divide both sides by 2, and we're going to get x equals natural log of 54 over 2, which we're going to round that as well. So 54, and then I'm going to hit the natural log, and then I'm going to divide that by 2, and I get 1.99449, and it keeps going. So tens, hundredths, thousandths, and it's going to be 1.994 for my answer on that one. All right, so let's look at the next one. All right, so on this one looks a little bit different because on these other ones we've had just a single x in a single unknown x in the exponent. Well, here we've got 2. So what you can do, this is what I would pause and look at first, because if it looks like this, it's going to be so much easier. So if we have the same bases on each of them, then what that means is that we can actually set our exponents equal to each other and solve for x. So I'm going to state that again. If our bases are the same, that means, because that would even be like something like this, 5 squared equals 5 to the what? Well, what would x have to equal? If our bases are the same and they both equal, and the left-hand side equals the right-hand side, x has to equal 2, right? We'd set those exponents equal to each other. Well, that's exactly what we're going to do for number 4. So because our bases are the same, we can set our exponents equal to each other. We're going to solve for x. So we are going to subtract 5, subtract 5, subtract 3x, subtract 3x. That's going to go away. So then we're going to have negative x equals negative 7, or x equals 7. Because you would divide or multiply both sides by a negative 1. So x equals 7. Check. And then I put the check in there because I was thinking, you know, if you plug it back in, you're going to get 14 plus 5, which is 19. And then the 7 times 3 is 21 minus 2 is going to give you 19 as well. So I was doing that little mental check. All right. Next one. This one is a little bit trickier than you may originally think. So here, it's similar to the process we're going to use in number 4. So the bases were the same, so we can set the exponents equal to each other. We'll look at what happens here. This time the exponents are equal to each other. Therefore, we're going to get to set our bases equal to each other and solve for x. But I want you to be careful. Because we have, and I wrote right through my problem, so let me erase that. Because it's being raised to an even power, what that means is that the x plus 4, it can equal 7. The x plus 4 could also equal negative 7. Because negative 7, so let's make sure you capture this, negative 7 raised to the 8th power, so this part, negative 7 raised to the 8th power will equal the same thing as 7 to the 8th, right? Because it's being raised to an even power. What happens if it was being raised instead, if it was like x plus 4 and it's being raised to the 5th power? And then we had 7 to the 5th. What about that? Do we have to account for the positive and the negative in that situation with an odd numbered exponent? No. So if we know right here that it's an odd power, we only have to account for the positive because this is positive. And so then on this one, I would just say x plus 4 equals 7, and so x equals 3, and that would be my answer. So again, because we have an even numbered power, we have to account for this parentheses. It could possibly be, that quantity could possibly be positive. It could also be negative. So you have to account for both those cases. So let's check that out. And you are probably, maybe you're already done with that one too. All right, so I wrote down the 2 cases already. So we could have minus 4, and x is going to give you 3. That's one answer. And this other one, it could give us x equals negative 11. So that's going to be our other answer for that one. So we've got x equals 3 and x equals negative 11 for that one. Okay, let's look at number 6. This time we've got an x in our variable. So what do? Or not our variable. We have our x and our exponent. So what are we going to do in order to bring it down? So to solve it, you should take the log of both sides. In particular, because it's 10, it'll be much easier if you take the common log, because we're going to get a situation that's going to look like this. And again, we've got a base here. And so 10 to what power is going to give me 10? So 10 to what power is going to give me 10? And that question mark is going to give me 1. So a similar thing is going to happen like what happened over here on number 3. So let's get started on this one. And so on this, if we're going to take the log of 10 to the 3x minus 2 equals the log of 13. Now we're allowed to bring this down. And we get 3x minus 2 times the log of 10 equals the log of 13. And this log of 10 is going to go away. It's going to become a 1 because of this over here, this process over here. And so then we get 3x minus 2 equals log of 13. Be careful on your order of operation steps here. So here we're going to add the 2 to both sides. And I am just putting that 13 in parentheses so I know I'm not going to be adding 2 to 13. I'm adding 2 to the log of 13. And then I'm going to divide by 3. So x equals log of 13 plus 2 divided by 3. So putting that one in the calculator, I've got some extra steps that I get to do on my simplified, very simple scientific calculator. And I got approximately 1.03798 tenths thousandths. So it's going to be 1.038 for that one. All right, next one. We have our x in the argument. So let's do a conversion where we're going to convert it into exponential form. So my base for a natural log is e, so it's going to be e to the 4.657 equals x. So e to the 4.657 equals x. So I'm going to put that one in my calculator too. You do it as well. And I got x is approximately 105.31964, and it keeps going. So we're going to have 105.320. So make sure that 0 is on there because that again indicates to your audience that you rounded to the thousandths place, and that you needed to put that 0 on there because it rounded up. All right, number 8. What do you think we should do? How should we solve for that argument? I'm hoping you're saying convert it. And you would be right. So we're going to have 7 to 3.843 equals x. So 7 to the 3.843 in my calculator is giving me x is approximately 1768.93456. Too bad it doesn't go 7. Wouldn't that be fun? All right, tenths, hundredths, thousandths. And then it's going to be approximately 1,768 and 935 thousandths for that one. Flip the page. Okay, directions are the same. Solve the following, round to the thousandths place. So here we go. On this one, look where our x is. X is in the argument. So what do you think we should do? How are we going to start this one? If it's in the argument, you should always start by converting. So we're going to go like this. So this time we're going to have 5 to the 1.96 equals 3x squared. We're going to divide both sides by 3. That looks kind of messy. So 5 to the 1.96 divided by 3 equals x squared. How are we going to solve for our x? We should use our square root property and take the square root of both sides. And so x in our exact form would be 5 to the 1.96 all over 3. Don't forget your plus and minus sign, divided by 3. So I'm going to put that in my calculator. 5 to the 1.96 equals, divided by 3 equals, and I'm getting like 7.8137. So it's going to be equals plus or minus 7.8137, and it just keeps going. And then I'm getting plus or minus 2.79530, and then that keeps going. So question for you. If you recall, we are not allowed to have a negative argument. So that's like from a couple days ago when, or maybe just yesterday. No, 2 days ago, when we talked about just a definition of a log. The argument in here has to be positive. But does this work? Does that work for us to have a positive and a negative answer? So look back to your argument. Is it okay for us to have a negative answer as well? What do you think? And the answer is yes. Yes, it's okay because we're squaring it. So any negative number that we get for x, if we square it, it's going to end up being positive. And then positive times 3 is going to give us a positive. And so it's totally fine that we're going to get a negative for a value of x here because we're going to ultimately square it. So rounding to the thousands, tens, hundreds, thousands, 2.795. And that's, sorry, I forgot my plus minus. Don't forget that. You miss a point on quizzes and tests for forgetting that. So don't forget that. All right. New type of problem, like new type of problem that we approach it a little bit differently. All right. So if you see on this one we have logs spread out all over the place, and then we have one x in an argument all by itself on one side of the equation. It could also be like we could have had like plus log of x just here, but the point of this being like you approach this type of problem all the same if you have one logarithm where you've got an x in the argument, and that's not what you have with all the other logs. Like all the other logs, you have numbers and coefficients in front of them and that sort of thing. So here's our general method that we're going to do for this type of problem. This type of problem, what I want you to do is to condense, use your properties of logs to condense this left-hand side. And once we get it into as condensed a form as possible, we're going to set the two arguments equal to each other, and x over here is going to equal the argument that we get this side all condensed to. And so we'll just finish simplifying it. All right, so that's our method that we're going to use for this one. So look at how this is different compared to the other methods we have used in this lesson today. So look at how this one looks different so that you can file that away in your brain to know that this process will be different compared to the other ones we've looked at. So let's work on condensing the left-hand side. So I'm just going to do a few things in this first step. So I'm going to take this and I'm going to move it up here, and I'm going to take this and I'm going to move it up here. So I've got log of 3 squared plus log of 16 to the 1/2 power minus log of 3 equals log of x. Well, I'm going to go ahead and simplify some things, and I'm going to say, all right, well, I know that this is going to be log of 9. If you don't remember what the 1/2 power is, you can, so 1/2 power is just taking the square root of 16. But if you don't remember that, you can put that in your calculator and you can just raise it. So like mine would look like this to the 1/2 power. And it's going to give you back 4. So you can do that. So it's going to be log of 4 minus log of 3 equals log of x. So now I'm going to combine these two pieces. So I'm going to have log of 9 times 4, which is going to give me 36. So then I've got log of 36, and I know that this subtraction is going to become division over my argument. So I'm going to go ahead and do that piece too, equals log of x. So then I get log of 12 equals log of x. And so because again, look, we're taking the log of both sides, they both have the same base. So because they have the same base, we get to set those arguments equal to each other, and x equals 12. And you would be more than welcome. What you could do in your calculator to check that, you could always go back and say, okay, I'm actually going to check to see what this side equals, and you would plug that side into your calculator, and you would do 2 times the log of 3 plus 0.5 times the log of 16 minus the log of 3, and then you would run a check, and you would say, does that in fact equal the log of 12? And just check it. You can totally check it if you're not sure that you're doing the right steps there. All right, we've got one more, and this one's so much easier compared to the one we just did. So here, again, we've got a log, we've got an argument here that's our unknown, and we've got this one here that's by itself. So some of my students actually like to move this over. In fact, most of you do this, move this over and then get x all by itself on one side of the equation. That's totally fine. And so if you did it that way, you would end up getting log of x equals log of 24 minus log of 3. And then this becomes division. So you're going to have log of x equals log of 24 over 3. And so x is going to equal 8 in that case. What I just have you guys do, and you can do it this way if you prefer, or you can do it this way, where I just look at what I have on this side and I know that that becomes multiplication. So it's going to be log of 3x equals log of 24. And then you can set this and this equal to each other. 3x equals 24, and you get the same thing, x equals 8. So whichever way you want to do it, go for it. You can do it either way. So what I want to do, I actually took some screenshots of your practice problems for this, and I'm just going to do a few of them because as you can see, they're a little bit more involved. They're more like this one, and I have a feeling you're going to need some more practice with that type. So I want to do a couple of those. And what I might urge you to do too is after we do one or two, you should pause the video and see if you can do a couple on your own and then see how you do. So I'm just going to look at that first one. So I'm just going to number these 1, 2, and 3. And so I'm just going to do one right here. So again, looking at what we're starting with, we only have the log of x on one side for every single one of these, and there's no other variable. So our process for each of these is that we're going to condense this side for each of them, and then we're going to set our arguments equal to each other and solve for x. So here I'm going to go ahead and put log of 2 to the 4th because I'm going to bring all of these up to be exponents like that. And then I'm going to have minus log of 64 to the 1/3. Again, don't forget, 64 to the 1/3 is like taking the cubed root of 64. If you don't remember that, this is going back all the way to order of operations, and we talked about this, where this becomes the index, and this would become the power on the number underneath the radical, so it would be the power on the radicand. Because it's 1, it's going to be 64 to the 1st, which is just going to give us 64. And then 3 becomes our index. So we're taking the cubed root of 64 on that one. Then we're going to have plus log of 6 raised to the 2nd power equals log of x. So then on this one, we're going to get log, and I'm going to start combining some of these. So 2 to the 4th is going to give you 16. And then I know that this subtraction is going to become division. So it's going to be 16 divided by our cubed root of 64 should be 4. And then I'm going to put plus log of 36 equals log of x. So then I'm going to get log of 4 plus log of 36 equals log of x. And make sure I'm doing okay here. And then we've got this addition is going to become multiplication. So it's going to be log of 4 times 36 equals log of x. And then you can either put that in your calculator or you can multiply it out. I think that's going to be 144, right? 24. Okay, yep, 144. All right. So we're going to get x equals 144 for that. What do you think? Think you can handle the other ones? I'm not going to do 2 or 3. I think you can try that one. So here's our answer, by the way. Let's try one down here, though. So we're going to call this one 4, 5, and 6. Which one looks like a harder one? Maybe the last one? Let's try that one. I'm going to try number 6. So number 6, we've got log of 31 plus, I'm going to go ahead and move these up because I know that's my next step anyway. So we've got plus log of 2 to the 3rd minus log of 64. Here's the cubed root of 64 again. Equals log of x. So then we've got log of 31 plus log of 8 minus log of 4 equals log of x. So then what you can do is that if you want to, you can actually combine the whole things if you want to. So you could do like 31 times 8 divided by 4 if you'd like. Or you can just do it step by step, and you can do 31 times 8. And then we'll do that next one in the next step. So 31 times 8 is going to give us 248 minus log of 4 equals log of x. So then we're going to have log of 248 divided by 4, which is going to give us log of x. And now you're ready to do some dividing here. So 4 is going to go into 24, I almost said 8 times, that's not right, 6 times, and then into 8 2 times. So we should be getting x equals 62 for that one. And good, there's an answer that matches 62 for that. And again, you can always go back and check, right? Like just put it in your calculator. And you could say, well, let me see, log of 31 plus 3 times log of 2 minus 1/3 times log of 64. Does that also equal log of 62? And just put it in your calculator and double check that the left-hand side decimal would equal the right-hand side decimal. And then you'd have it. I'm going to try this one. So number 4, we would have, again, I'm going to go ahead and move my exponents up in this first step of me rewriting it. So I'm going to have log of 4, we're going to raise it to the 3rd power, plus log of 16, and I'm going to raise it to the 1/4 power. So you're taking the 4th root of 16, or what to the 4th power is going to equal 16? That's another way to ask that question. Minus log of 2 raised to the 2, and then that equals log of x. So then we're going to have log of log of 64 plus log of 2 minus log of 4 equals log of x. So then if you want to, here's what I was talking about earlier, where you can just start combining them if you start feeling more comfortable to do this. If you don't, just do these first 2 like we've been doing and then add in the next piece. But if you would like to, you're more than welcome to do 64, and you just have to show the step. Show me that you're doing it this way. Equals log of x. And then you should be getting 128 over 4, which is then going to give you 32. So 32 equals x for that one. So it's right here. All right, I'm going to leave the other one for you guys to do. And it's not, these were just extra problems. So these are ones you might just see on the practice problems. And so I just did some extra problems. So it is not assigned for you to finish. I'll repeat that. It is not assigned for you to finish these other examples that are in here. So you do not need to do 2, 3, and 5 on your own. But those are other problems that you might see definitely in your practice problems. So just a heads up on that. Okay, that's it for this video. Thanks for tuning in, guys.